All right, so I'm going to suggest that you work on the concept check by yourself and see if you can actually do it. Instead of listening to me do it, the filled-in version of the notes will show you if you're right, and I think you have enough information at this point with the filled-in notes to figure out if you went wrong, where you went wrong. And I'll go a little bit further with you. Okay, so now we're going to be looking at some inverse trig functions. So this chart is given to you just for your reference. Okay, I know you've seen the inverse trig functions before because they undo the trig functions. That's why they're inverse. Their domains and ranges are slightly different because of the fact we actually want them to represent functions. So with these domains, this basically ensures that you are going to pass the vertical line test. Okay, one really important note. The -1 here is not an exponent, right? Still. Okay, it is just telling you that it is inverse. Okay, and so sometimes you will see, and I think that a lot of times the AP test does both. Okay, you might see y equals this to mean inverse cosine, and it literally is the same as y equals arc cosine, right? So those are interchangeable, and that is true in the AP test as well. I think your book tends to prefer arc, just so there's no confusion with that exponents. Okay. Also for your reference, I put all of the trig inverse graphs here. You can see that they all pass the vertical line test for that reason. So it's nice to have some familiarity with specifically probably the domains more than anything else. And I would say the top 3 are more important to you than the bottom 3, and especially this one will be important to us for sure in terms of graphically. Okay, so probably worth doing some familiarization there. Remember, these are just a regular trig graphs reflected over y equals x, and then restricted so that they actually form a function. Okay, let's take a little bit of a look at arc sine. Okay, we know that there's a couple different ways to write the notation, so that's not super surprising. And so we can either write arc sine of x, right, or we can write sine inverse of x, same thing. Okay, that domain, -1 to 1, which it used to be the range, if you notice, right? And the range is -pi/2 to pi/2. Okay. All right, so a little bit hard to see here, but if we do that reflection over y equals x, I'm going to do my best to kind of just draw it in real quick for you. That's not really my best line here, but that's okay. I know you guys know what's going on, right? And then I do the reflection of that. See if I can use my skills here. I imagine you kind of watching this at school, and I think it's throwing my game off a little bit here. But basically kind of something like this, and then restriction so that we don't actually have that issue with actually being a function, is what I'm trying to say. Okay, so that's where the graphs all kind of come from. And then we will say more in terms of using them in just a second.